Hello, do I need this one? No. No. You can hear me?
It's probably good to talk into that because
The video, okay.
the video will
Oh, yeah. Okay. I'm sorry, this is my first time going to GUADEC. I am one of the committee in the Genome Asia 2015 in Indonesia. So this is someone from Asia too. Yeah, we conquer the world. Arun Ragavan will deliver a PulseAudio status update, so you're gonna watch it. Go. Thank you. Please give an applause.
Okay. All right. Right. So I'm going to do a talk about sort of the audio stack, and it was supposed to be a PulseAudio status update, and I was wondering, okay, from what point do we need an update? And I looked at the previous GUADEC talks, and I think the last one was in 2006 or 2007, when Dana was still writing quite a lot of PulseAudio. So it's going to be somewhat more high level than I initially planned, because I figured that there's a lot of sort of stuff that's happened since PulseAudio was last at GUADEC. So just a quick introduction to myself. I'm here from Bangalore. I work on PulseAudio and GStreamer. Currently, I'm doing sort of something similar to what the Center Killer folks are doing, which is working on these projects in my free time and also doing consulting around them to fund my free time. So that's a little bit about me. So I'm going to break this down into three sections, right? First, I want to talk about what we're trying to do as a project, like where are places in the GNOME stack. Then I'll talk a little bit about what we've been doing for the past 2 years that might be interesting to you guys. And then finally, about where we're going to go from here. So the first part is, what do we do? So the simplest sort of use of PulseAudio is, say, in playback. So you have an application like Totem that plays out video via GStreamer as the multimedia framework, and then that talks to PulseAudio. And PulseAudio then talks to the underlying hardware API, the API that exposes the hardware to user space. So it could be ALSA if you're talking to your built-in microphone or speaker. It could be Bluesy if you're doing Bluetooth audio. And it could be anything else as well. And that finally goes out to the hardware. So that's broadly where we are. So what I'm going to be talking about is effectively this part. Right. So our primary task is effectively to mediate access to the audio hardware. So effectively, one sort of incidental fact is that in most cases only one program can access the audio hardware. So you need some way to allow multiple things to access it. So if you have multiple clients playing back audio, mixing it and stuff like that, all of that, you don't necessarily need an audio server to do that, but it does make it easier. But our job is to sort of sit in between all this, understand the state of the system, and then work with that. So that includes providing an arguably convenient API to clients, but anytime you think that the PulseAudio API is bad, you should go and try writing native ALSA applications, and then you will thank us. But yeah, what we do is we try to make it possible for the application to not care about what does the hardware support in terms of what audio format does it support and what kind of buffering do I need to do and things like that. The idea is that application writers should just be able to say, I have this audio stream, I want to play it out, take care of it, right? That's our goal from the application developer's perspective. We provide routing, so what that means is you may have multiple clients playing back concurrently, and you may have multiple audio devices, and we want to be able to say, okay, play this out to this hardware, play this out to this hardware. You might have hardware coming in, going out. We need to be able to manage all of that. And the other big piece is policy. So for it, this is basically the part where we need to be able to sit in between applications in the hardware and also understand the state of the system, and then take possibly take action based on that. So the canonical example is you're playing music with Rhythmbox and a phone call comes in on Skype or whatever you're using. And we need to be able to understand that there is music playing, there is a phone call coming in. Can we pause the music and take the call, and then end the call, and then allow music to start again? Things like that are also where PulseAudio fits in. And the final thing that we allow is control. So when you open up Control Center and open the sound panel, you see what hardware is available, potentially what applications are playing out, and you want to say, I want to use this this output by default, or use this input by default. And we allow things like moving streams from one device to another on the fly, completely transparent to the application, managing volumes, all of that. So our job is also to provide access to all of this. Right. And those are sort of the big pieces of what our mandate is within the GNOME stack. But it's not all that we have to do. Ideally, we want to do all of these things in a way that allows you to expend as little power as possible. So one of the things that we do is, if you have a music player, you can buffer up a lot of data and feed that out to the audio hardware, and that saves you power. You can't do that during a VoIP call because you want to minimize latency in that case. So what we try to do is, based on what applicants say they need, we can adjust how we're using the hardware to save power. There's more stuff that I'll talk about in the next section as well. The other thing that we do, which is now pretty much a given, like you don't even really think about it, is we actually store a number of user preferences. When you adjust application volumes, we store that. So when you started Rhythmbox and set it at like 35% volume, you restart your computer, start Rhythmbox again, it's stored at 35% volume, we take care of that. Maybe you have a separate volume for your headphones versus when they're not plugged in, we store that as well. You have preferences for what device you prefer to use, or what device you want to send a particular application to, we store all that as well. And the other thing we do is we have a bunch of filters to kind of work with the audio stream. So you have an equalizer, we have a virtual surround sound module, we have some other stuff, the echo cancellation stuff, and I'll talk about all of that. But that's broadly all the things that, well, that's not all the things that we do. Those are the sort of big pieces of the kinds of things that you do within PulseAudio. And I mean, there's a lot more that's sort of more related to plumbing than to what would be user-facing, so I've not spoken about most of that. So, yes, so I'm going back about 5 years because that's approximately when we did 1.0, and then we've been trying to keep some sort of steady release cadence with limited success, but at least we're now almost on 7.0, so we're not completely screwing it up. Things that we did since then. We added echo cancellation. Wim wrote the initial echo canceller module. The idea is that when you're on a voice call, if you're you're using your laptop speaker and microphone, there's going to be feedback from the speaker into the microphone, and the other end gets to hear everything they're saying, which is super annoying. So we added a filter module to cancel out the bits that are coming in when you're doing capture. We started with an implementation of the algorithm that Speaks has. Then we took some of the code that Google released from the WebRTC project, which actually made it a lot better. So we have a pretty good echo canceller in PulseAudio. This used to be useful when you were doing you were using empathy. It's not used so much with the more recent things that people are using. So Skype has its own thing, Google Hangouts has its own thing. The WebRTC stacked in both Firefox and Chrome, basically they all do their own thing. But eventually, I like for it to be possible for us to implement, to sort of expose this to all applications, including the browser, and have the browser offload it to PulseAudio. We added pass-through support. This is basically you have an AV receiver at home which can do DTS or AC3 and stuff like that. And we added the ability for your application to effectively stream out all of this directly to the receiver. There's still some stuff to be done here, which I'll talk about. We added support for alternate sample rates. This is a power saving feature again. So usually, especially on your desktop class hardware, your audio hardware can run at various sample rates. It can run the two typical sample rates that you would deal with are 44.1 kilohertz and 48 kilohertz. And if you always open the device to 44.1, then all your 48 kilohertz streams need to be desampled, and that can be a CPU expensive operation. So what we try to do is, based on the stream that's coming in, we reconfigure the hardware, like we open the hardware for the appropriate sample rate. So trying to minimize the amount of resampling that we're doing. That was one thing that we got from Pierre-Louis Bossart at Intel. So that was a nice thing to have. The other thing that David Henningsen here wrote was jack detection. This is a pretty basic thing. So what I was talking about before, for example, where you want to have separate volume for when you're running on speakers versus when you have headphones plugged in. Before we had jack detection, we had no way of knowing what's plugged in and what's not. And with this, we now PulseAudio is aware of what is plugged in, and we are able to, for example, do things like good for port volume, or be able to see what's plugged in and what's not, and then make routing decisions based on that. So if something just got plugged in, you probably want to use it maybe, and then you say, okay, let's start playing to this output, things like that. Before this was kind of hidden away. Alsa took care of some of it, and some of it we just didn't have the ability to use. We improved our support on ARM platforms. A number of things happened here. We added Neon support, so that's we have a number of CPU optimizations within PulseAudio when we have to deal with samples. If you're converting between audio formats, when you're doing resampling, when you're applying software volumes, all of these they're not very CPU expensive, but they do incur a CPU cost. And so what we did was we added support for decreasing the CPU cost by using vector instructions. So we have a number of Neon implementations for what we already have in x86 with MMX and SSE. This was written by Peter Meerwald mostly, who's not here right now. That was one part of the ARM support story. The other thing that we added was support for the ALSA use case manager. Right, so usually laptop, if you opened up the ALSA mixer controls on your laptop, there are like 5 or 10 of them, and we usually say that's a bit too confusing for users. If you open this on a decent Nexus device, you open the list of ALSA controls, there are probably about 300 of them. Right? And the reason, they're very different, they're a different beast in some sense, because it's usually a much more complex bit of audio hardware that you're working with, and it's much more flexible and lets you do a number of things like it supports a number of outputs, supports voice calls, and you can arbitrarily kind of route things within the audio chip itself. And all of this is exposed to user space via ALSA controls. And that means that we can't, it's not always as easy as with your desktop hardware to just say, play music out of the headphones or play music out of anything at all. And so for that, the ALSA folks wrote a configuration format that lets you sort of declaratively say, okay, these are the use cases that my hardware supports. And within these there might be a hi-fi use case which is just play music. And within that, you want to say, this is how if you want to play to headphones, you need to do this. If you want to play to speakers, you need to do this. If you have a earpiece or a mic on the handset, you need to do this. So all of that was expressed in some configuration format, and we wrote support in PulseAudio to effectively pull that information in, map it to PulseAudio concepts, and so basically take that configuration and allow you to use that to run PulseAudio on these devices relatively easily. So we did that as well. Let's see, what else did we do? Right. This is probably the most user-facing thing that we saw. Way back, if you looked at the GNOME audio configuration screen, the sound panel, it was not very user-friendly. So you had the idea of cards have profiles. Depending on the profile that you enable, you get certain syncs, and those are the devices that you work with. So you get between the stereo profile and fighter point output, things like that. And from a user perspective, that's quite ugly, right? Because if you give a user a device, what they want to say is, I want to play this out of my HDMI device, or I want to play this out of my speakers or my headphones or whatever. So again, David did a bunch of work to kind of allow us to do use ports, which are kind of our routing endpoints, and build effectively a way to make the UI ports rather than the other sort of concepts that are further away from the actual hardware. And in between, the other thing we had to do was Bluesy 5 support. So when the Bluesy project moved from 4 to 5, they kind of removed a bunch of functionality, and then there was nobody left to take care of that. So what that meant is for 2-3 versions of PulseAudio, your headset didn't work at all, right? And we were sort of somewhat left in the lurch because we thought, okay, the Bluesy folks should take care of this part, and we didn't really get to a point where we were like, okay, have any agreement on how this should be done. And finally, we felt we got to the point where we regressed long enough that we need to do something, so we kind of incorporated all that in PulseAudio right now. Wim wrote all of that, and it's working reasonably well. We still have some bits left, where if you want to use your laptop as a headset, so you've got your phone, you can use the laptop, you can use the laptop to take the call, for example, to take the audio calls. That doesn't work yet. That will be merged, hopefully not in this cycle, but in the next cycle. So that's the other thing that we were working on. We added systemd support, which was relatively easy. What this means is socket activation for your user sessions was added, and some bits for supporting the journal and doing logging. Again, this is not a big thing. It was fairly straightforward. I think the socket activation stuff still needs to be done properly. Like, it's not 100% there yet. It's still a work in progress. But this is another interesting bit. This is more plumbing than something that you would notice higher up. Again, this is something that David wrote. The SRB channel is a shared ring buffer channel. How PulseAudio clients talk to PulseAudio, you have two channels of communication. One of them is a Unix socket. That's where you have your control channel, and you say, okay, I need to set up a stream. I need to maybe like create a sync input, create a source output, set volumes, etc. And you also have a shared memory block which you share with PulseAudio. So you basically tell PulseAudio, hey, I'm sending you audio, and then you actually transfer the audio samples themselves using a shared memory block. The reason you do this is for efficiency. A shared memory block means that you don't have to do another copy of all the audio between clients and the server, right? What we found is that as you work with lower latencies and you're working with smaller packets, the second control channel was effectively not allowing us to be as efficient as we would have liked. So we effectively added a shared memory channel for sending commands as well, right? And this did help improve our performance in low latency cases. So that was pretty cool as well. Right, and we have better bits. This is the actual thing. So again, David and Alexander, who I don't see over here, effectively, so some laptop hardware, especially MacBook Pros and a bunch of others, actually have a subwoofer built in, right? And we didn't really support that very well. You basically need to send out the low frequency bits to the subwoofer, and we didn't really support that. So thanks to David, Alexander, the Chrome OS folks whose LFE filtering we actually first worked with, and Huibang as well, we now have LFE, like an LFE filter to actually feed the subwoofer. Yes.
So that's something I wanted to ask earlier, but now that you mention it, I do happen to have a surround sound system set up at 5.1, and so PulseAudio nicely spreads the sound across the channels, across 4 speakers, except the subwoofer. So are you saying that in the next version or something, it might now spread out the low frequencies and send them to the subwoofer?
That should have worked already, right?
You want to repeat the question?
Oh, sorry. Right. Good question.
Okay, so I have a surround sound system, 5.1, on an Intel chip on a desktop computer. At least with the current versions of PulseAudio, I don't get the sound being split up and sent to the subwoofer, just across the 4 speakers, but not the 5th one, which is the subwoofer. So I'm wondering if that's something that's coming in the next version with this, or if I should file a bug report.
I think maybe David. Yeah, David could probably answer that.
Okay, so the answer is, first there is a key in the configuration file which is called enable LFE remixing, which you need to enable. If it's enabled in the past versions of PulseAudio, the subwoofer speaker will get a mix of all sounds. So if you have a hardware filter on your subwoofer, this will probably work okay. What we do have in the new version is that we also have a filter in PulseAudio itself, so it only sends the low frequencies to the subwoofer speaker, whereas in the previous version it would send all frequencies to the subwoofer.
And therefore, why don't you remove the options and just make it the default? So that it sends it to the subwoofer, is that?
In the new version it is the default to enable it.
Okay, so I won't have anything to do. Right.
Hopefully.
Except for buying us beer.
Yes.
Yes. Right. Another thing that happened that, well, it didn't really involve a change for anybody, but it was good to know, is Alexander did like a pretty nice evaluation of all the resamplers that we have, kind of like testing them against what OS X and Windows, etc. provide to see how we fare. On synthetic benchmarks, our resamplers are actually could introduce artifacts, but in real life apparently they don't. So we decided not to actually change them. But that was quite a large body of work, and it was quite interesting. At least if you're a audiophile or an audio geek. So yeah, that's kind of. I mean, there's a lot more that went on in the last 5 years, but most of it is plumbing that might not be very interesting to everyone. So the Bluesy module got rewritten to be sort of easier to hack on. Lots of bugs got fixed. Lots of small changes came in. And we actually have also a fairly diverse set of contributors. So usually we have something like 20-ish contributors, different contributors for each release. So yeah, but that's roughly the highlights of the last 5 years at least. And what is next? Right, one thing that I would like is scriptable policy. So you can actually, right now, if you have something that you want to do that is sort of a very specific use case that not a lot of users want to do, you probably have to sit down and write a C PulseAudio module. And I think that's not strictly necessary if you can provide some sort of simple scripting language like embed Lua or something and let you write your own policy for your use cases. This would be nice to have. And this would be nice to have in general for embedded users as well. So people who are adapting PulseAudio for cars and phones and whatever else, giving them the ability to write policy without having to write a policy module, which has a lot of boilerplate and not strictly, it's not strictly the best use of your time if you're just trying to enable audio use cases on your hardware. Something I've been harping on for a while, and that I don't think we have agreement on within the PulseAudio developers as to what this means and how we do it, but what I would like to have is a configuration framework where you can configure parameters for various PulseAudio things. And it's very vague because right now you have configuration that is in a configuration file. So, for example, the LFE remixing is a configuration parameter, the default sample rate, etc. are parameters for the daemon. But you also have configuration for filters, for example. So the echo canceller, you can have automatic gain control. So your mic sets the volume according to the input level, but sometimes people don't want that. We have noise suppression, and we have parameters for tuning those things. Then you have, just on your ALSA devices, you can have various things like, if you know that your hardware has bad decibel information, right? So that tells it what the volume levels on the hardware mean. And sometimes it's just, like with USB devices, for example, you just get bad decibel information. You want to maybe have a configuration thing that says, go pick this thing somewhere. It can be a setting that's not very easy to get to, so you don't confuse your standard user, but it would be nice to just say click this thing and it'll work, right? And it's right now it's quite annoying for someone to come on PulseAudio on IRC and say, hey, this is happening, and I'm like, okay, now either I need to explain to you a set of things to do, which it seems to me, even I find it painful to explain, so it's going to be painful for you to do, or you're kind of stuck. So I like to avoid those sorts of situations. And I mean, having a configuration framework means that you can effectively tweak things and have it in a nice way. Like right now we basically use gconf and for some stuff we basically talk directly to some of our modules via our protocol. But I think we could do this better. Improving filters is another thing. Our equalizer is not that great. It introduced a ton of latency, and Alexander's pointed a bunch of problems with it. And generally our filter framework itself could use some, I think could be made better. Pass-through support, which I was talking about, hasn't really been integrated into the GNOME UI per se. That's something I want to take up this weekend. Whether that goes into Totem or into the sound panel or not at all is something that we need to decide. But basically the ability to say, I have this receiver, it supports AC3, does not support DTS, maybe supports AAC, and have that as, again, configuration that we can remember that configuration, but it's really nice for users to be able to just say, hey, this is what I have. And that's been sort of due for a long time. This is right now not very relevant on the desktop, but increasingly the kinds of laptops that you're working with, you're going to see this. You have your hardware device, which is actually a DSP followed by your codec, which captures or sends out data, can do MP3 or AAC decode, right? So how this is exposed to you is ALSA has this compress API, which means you can give the hardware MP3 or AAC directly, and the hardware just decodes and plays it out, right? And it's far more efficient than doing it on the CPU. We've got some people who kind of implemented this for a smartwatch and are using PulseAudio with it, and we're trying to see if we can get that upstreamed and actually have it working well. So yes, this is something I would like to have. It's again something that makes things much nicer on embedded devices. Sandboxing is something that Wim has been looking at, and I think there's some interest from the Ubuntu phone side as well. The idea is that currently, if you look at the PulseAudio API, it's basically everyone's trusted. Anyone can do whatever they want. You can move other program streams around. You can listen in. You can do effectively anything. And this is, I mean, we didn't get very close to this thing because it's always hard to look at an API and then try to add security as an afterthought. But the approach that Wim's got seems quite promising, and we might be able to get something done without a radical sort of restructuring of our internals. So I'm hopeful that we will have this sort of working well before too long. Overall, the way our users interact with the sound panel, the sound reference panel, I think there is room for improvement for us. Currently, it's a very sort of high granularity of control. You can just say, I want all output in to this device or to this device. I can't say, okay, I've plugged in HDMI, but I just want totem to play up to my TV and I don't want everything going out there, right? Things like that. I'm not sure that this is actually something that we should do, but I think it would be nice to sort of have some conversation around whether we need to be adding more features to the sound panel. Another thing that has been coming up is flat volumes. Some people hate it, including, I think, David definitely doesn't like it. Actually, I might be the only one on the team right now who does like it. But yeah, so this is something, again, we'd like to talk to the GNOME UX folks and say, hey, okay, does this make sense? Other things we could be doing better? Or should we just be like disable it or throw it away, right? Things like that. Right, and in general, all of us are around for this weekend. Tomorrow we're sort of having a developer meet/hack test. So if you see me or Tanu or David around, feel free to ping us, or even now, if you've got ideas of what you'd like to see, or stuff that doesn't work for you that you want to rant about, which obviously there's no such thing. But yes, please talk to us, and we definitely like to make sure that things are working well for everybody. I think that might be all I have. Yes.
Is the oh yeah.
So in terms of the sandboxing stuff, I guess you've mostly been more looking at permissions and things like that.
Mm-hmm.
What about the long-term ABI or IPC stability of the protocols?
Right. We've tried to make sure that we don't actually break backwards compatibility at any point. So if you look at our protocol is version, so whenever we add new stuff, we bump the version. So at least it's very hard to test.
Yeah, but so in a sandbox world, you'd be much more often in the case where you have an old client library and a new daemon.
Mm-hmm.
But that's supposed to work, I guess.
Right. So yeah, it is supposed to. So the approach we've been talking about is that you'd effectively have permission control as a sort of, is not part of what we do at all. You'll have a policy module that can effectively figure out by some mechanism whether access should be given or not. So this might involve like a dbus call out, might involve like something that gets user input and then comes back.
Yeah,
things like
yeah. I'm actually more worried about the case where you rev your host OS and an old sandbox version has an old PulseAudio and
right.
The protocol changed in some way that doesn't work with the new daemon.
So our objective is that it should never happen.
It should never happen. And also the new shared memory stuff. Can we consider that safe?
No, it's
No.
shared memory. You can't consider
Yeah.
it, right?
So we should be using the pipe stuff.
Yeah. No. So you can disable shared memory, right? Then everything happens over the socket.
In this context, what exactly does shared memory mean? Is it an MF file or is it?
It's an SHM. It's like
System file, shared memory.
yes.
Okay, so
Yeah. So effectively for proper sandboxing, we'd have to disable all of the shared memory stuff. Something to look at that I kind of missed in this is maybe what we should be looking at then is something MFT based.
yeah, that would be pretty cool. I mean, and you can also do, if you don't have MFT, you could just send temporary files and that and.
Right. Well, so
Yeah.
this IO might not be that nice to have.
No, it could be a FS base.
Back thing. Well, MFT seems to actually fit very well with what we would want to.
Sure.
So if you can do that, I'd be like.
Yeah.
It depends on performance as well. Like can we get the kind of performance you want on low latency, and not have kind of overhead, and maybe we implement it and find that we have it, and maybe that's something you can fix as well.
Have you looked at all at the automotive audio routing use cases?
Yes. So I believe that at least the Geneva folks, for example, do have PulseAudio as included in their base system. I thought no.
Tizen IBI uses it. Geneva has a tool called the Audio Manager.
Right. So the idea with, I mean, Audio Manager should be able to sit on top of PulseAudio. There are things that we could do better. Something that some of the Intel folks were looking at was actually sort of routing layer on top of PulseAudio concepts that would pretty closely match to Audio Manager. Unfortunately, we got stuck sort of because it sort of became a pretty large project of its own. But I mean, the pieces are there, and we could build that if we wanted. So I would like to see PulseAudio in as many places as possible. So if it if there are things we can be doing to make it easier to use in IVI use cases or mobile use cases, I'm pretty happy to look at those.
Just for your information, I run PulseAudio on MIPS 64 year, and it's quite good work.
Oh really? Awesome.
You see MIPS?
So we all know that there are no bugs in PulseAudio. When is your hackfest tomorrow?
All right. Well, we need to find out when we have a table to sit at. But we also have a BOF scheduled for later in the week. I think that's for the 11th. Tuesday. Okay. Whichever day Tuesday is, that's when we have a BOF as well.
I'll be here all week. I'll be your worst nightmare.
Excellent. Right. So we'll be there we've got a half-day BOF. So yeah, if you guys would like to sit with us and see how there are no bugs. I think there's a question on that.
I just want to complete the picture, Jeremiah. So the Audio Manager set up in Geneva is basically a framework with a number of APIs for plugins that basically implement sources and syncs in the way that the audio folks are used to.
Mm-hmm.
And there are some implementations that do use PulseAudio for the actual plumbing. So I think these complement each other rather than compete. So
right. It's sort of like a generic control interface rather than something based.
Exactly. So it's the logical way to do it, I think, in most cases.
No.
Cool. All right. Thank you very much.
Is there a speaker gift?
Yeah, there's a second speaker after this one.
It's right there on the
Yes, thanks.
Oh yeah.
Express gratitude.
So this is extra seal. I have to deliver the thing. Thank you so much, someone from Asia. So thank you everyone. We'll have another talk. Oh, you. Make sure you are wearing.
Yeah, I think.